Hello student, welcome to this topic, back titration. Back titration is a method of volumetric analysis used to determine the concentration or the quantity of a reactant. It involves reacting quantities of substance being analyzed with excess amount of a suitable reagent whose volume and concentration is known. The amount of the reagent that reacted with the analyte is determined by subtracting the excess amount from the initial. The data obtained is then used to determine the concentration of the analyte. Example, to make this concept clear, very simple. Put 0.5 grams of divalent carbonate, X carbonate, di means 2, valency, in a conical flask. 30 centimeters cubed of 0.5 molarity of HCl was added to the X carbonate. 2 to 3 drops of phenolphthalein indicators were added into the conical flask. Titration was carried out against 1 molarity of sodium hydroxide solution until the color of the solution just turned pink permanently. The average volume of the base used in the reaction was found to be 5.0 centimeters cubed. 1. Determine the number of moles of the base used. 2. Write a balanced chemical equation between sodium hydroxide and HCl. 3. Determine the number of moles of sodium hydroxide that reacted with HCl, that will be the mole ratio. 4. How many moles of HCl reacted with sodium hydroxide? 5. Determine the volume of the acid that was neutralized by the base. 6. Determine the excess volume of HCl acid, and this is the amount that reacted with X carbonate or the divalent carbonate. 7. Write down a balanced chemical equation between X carbonate and HCl. 8. Determine the number of moles of HCl that reacted with X carbonate, that is a mole ratio between HCl and X carbonate. 9. Determine the number of moles of HCl that reacted with X carbonate. 10. Determine the number of moles metal carbonate, the number of moles. 11. Determine the relative formula mass of the carbonate. And finally, determine the relative atomic mass of X. This question is usually very simple, and I want you to follow step by step, and it will be very easy. Here, we need to appreciate there are two types of titration. The first one with the X carbonate, and the second one with excess HCl with sodium hydroxide. So these are two titration, and you'll find that in each we have 6 questions. Let's work them out. Determine the number of moles of the base used. Remember, this is the volume used, and this is the molarity of the sodium hydroxide. So we know the meaning of 1.0 molarity. It is the number of moles in 1,000. So therefore, 1 mole in 1,000 centimeters cubed. What about 5 centimeters cubed? So we'll get the number of moles to be 0.05 moles of sodium hydroxide. 2. Write a balanced chemical equation between sodium hydroxide and HCl. So the balance equation is there, very simple, because it's a basic acid, so the reaction ratio also is 1:1. So determine the number of moles of sodium hydroxide reacted with HCl. So from the equation, the balanced equation, then the mole ratio is 1:1. Therefore, how many moles of HCl reacted with sodium hydroxide? With the information about the reaction ratio, and we know the number of moles of sodium hydroxide as 0.005, then the number of HCl will be the same, because 1:1, therefore the number of moles of HCl will be 0.005 moles of HCl. Then 5, determine the volume of the acid that was neutralized by the base. So what do we know about the acid? We have this value 0.005 moles, and we knew the molarity was 0.5 if you look at the question, which means 0.5 moles are present in 1,000, the meaning of the molarity. So what about in 0.005 moles? So when you do that calculation, 0.5, that's the molarity, and we have the number of moles, then the volume that reacted was 10 centimeters cubed of HCl. So this is a volume that reacted with the sodium hydroxide, and you are going to notice that this is the number it reacted with the sodium hydroxide. Therefore, determine the excess volume of HCl, the amount of HCl that reacted with X carbonate. We were provided 30 centimeters cubed of HCl, meaning what? That if 30 took part in the reaction with the HCl, then the remaining was 20, and that is why this reaction is known as back titration. We start with sodium hydroxide instead of starting with the X carbonate, which reacted with the first portion of the HCl. So therefore, the excess will be 30 minus 10 to get 20 centimeters cubed. This is the volume of the acid that reacted with the X carbonate. We proceed. Write down a balanced chemical equation between X carbonate and HCl. Remember, it is a divalent carbonate. So when they react to form X chloride and carbon dioxide and water, because it's a carbonate, it forms 3 products, then that will be the balanced equation. And note, determine the number of moles of X carbonate that reacted with HCl. Mole ratio is 1 mole reacting with 2 moles. So 1 mole into 2. Determine the number of moles of HCl that reacted with the metal carbonate. So the number of moles, we know the concentration of HCl, and we have the volume that reacted. So the number of moles was 0.5 moles in 1,000, that's the molarity. So what about in 20? In 20 centimeters cubed. So the number of moles will be computed this way by cross multiplication. 20 times 0.5 divided by 1,000 to get a mole of 0.01 moles of HCl. Determine the number of moles metal carbonate. The reaction ratio was 1:2, and these are the number of moles of HCl. So you place them here, and to get the number of moles of X carbonate, you cross multiply to get 0.005 moles of X carbonate. Then 11th question, determine the relative formula mass of the carbonate. So we know 0.5 grams of metal carbonate was weighed, and now we have the mole of X carbonate, which is 0.005 moles at 0.5 grams. So to know the relative formula mass, we ask ourselves about in 1 mole. So we cross multiply to get the relative formula mass of 100 grams. You may replay this video to get the concept and maybe do some pauses so that you can understand and also internalize. The notes are also provided for your revision and also more exercise. Then the last question, determine the relative atomic mass of X. So the formula of X carbonate was that. So the formula mass is X, that we don't know, plus 12 for carbon, then plus 16 times 3 for oxygen. This will give you the relative formula mass from the 11 above. So this one will give you to 100. So when you add, you're going to get X will be 100 minus 60. So the relative atomic mass of X will be 40 grams. Thank you. A quiz to test your understanding on back titration, which is a very simple question. Just have an open mind, read sentence after sentence to internalize, then work out. There are 12 questions and the answers are provided. The second part of the quiz is here. Read. They are very simple. Back titration is an examinable area. Please work hard. Bye and thank you, and let's meet in the next lesson on redox titration. Bye.